Okay, welcome back. This is the ENG 460, and today we're going to look at printing floating point numbers. So I've got a demo program here, demonstration of printing single precision floating point number represented by IEEE 754. Okay, so let's look at the data segment. Okay, data segment's nothing new. I got my little title here, normal termination. I've got a prompt here to enter a floating point number, and then I have a prompt here to echo back what you entered. Okay, so there's nothing really new there. Okay, here's my text segment, and global main, and then I basically print out my title. Okay, and then what I do is I print out another string, but this time it prompts the user to enter a floating point number. Okay, now the way you read in a floating point number is this: you automatically read it into F0. Okay, so the result ends up putting in F0 whether you want it to or not. So you don't typically want to use F0 for other stuff because that's your I/O port. Now, what you do is you load V0 with 6. So you kind of remember, like when you loaded V0 with a 4, you printed a string. When you loaded with 1, you printed an integer. When you loaded with 5, you read an integer. And now when you load it with 6, you read a floating point. So just load it with 6, call syscall, and your program will suspend until you type in a floating point and hit return. Okay. Then after we read it in, now it'll be in F0 after syscall executes. Then what we do is I print out a prompt that tells me this is what you entered. And now, in order to print out, you have to move it into F12. Okay, so you read it into F0, you print it out from F12. Well, it's currently in F0, so I have to move it from F0 to F12. And I have a move.s for single precision to move the contents of F0 to F12, and then I tell V0 to equal 2. Okay, V0 equaling 2 means print a floating point. V01 means print an integer. V04 means print a string. All right, so you have all these different V0s. And here, when you read a float, it's 6. When you print a float, it's 2. Then call syscall, and it'll print back out. All right, let's go ahead and save this. I will load it, and then we will step through it. Okay, let's move my console over here. Okay, and I will do File, Reinitialize, Load File. We'll load this float guy. There's my text. There's my floating point registers right there. Okay. So let's come along here and just step through. Okay, we just loaded V0 with 4. We load the address of title. We execute syscall, and there you go. Demo print floating point number. All right. So now I come down here. I load V0 with 4. I load address into A0 of the enter F read string. And then when I call syscall, I get a prompt to enter a floating point number. Now let's do something here. Let's do 0.625. Enter. All right, I just entered 0.625. And now that guy should be in one of the floating point registers. Okay, do you remember which one it goes in? Well, you read into F0. So at this point right here, let's actually go look at F0. And where is F0? Oh, am I not that far along yet? Let's see, what do I got to do here? Oh, that was the prompt. Never mind, I'm done. That was the prompt. Okay. So then I do syscall, and there's my 6.25. Now that guy should be over there. Oh yeah, I kind of screwed up. Oh, that's all right. But yeah, there you go. It's 3F2000, and that corresponds to single precision. Most significant bit is the sign bit. The next 8 bits are the exponent bits, and the remaining 23 bits are the fractional bits. Okay, so now we're going to load immediate V0, and now I'm going to call syscall, and I'm going to print out a string that says the float you entered. Okay, so now what I have to do is I have to move F0 to F12. Let's move F0 to F12, go look at my floating point registers. Notice F12 has the same value as F0. And then let's actually go back to here. That's interesting. It's updating. Oh, I see. That's interesting. Yeah, I can either look at F0 and 12 through the double precision, or I can also look at them through the single precision. Okay, that's nice. So now we're back here, and what we're going to do is actually print it out. I moved F0 to F12 because you read into F0, you print out at F12. Now you set up V0 with 2, and as soon as I call syscall, I'm going to print that guy back out. And there you go. We just printed out 0.625. Okay. And then the rest of my code just kind of cleans house, little normal termination message, and then we syscall. All right, now let's run it again. Let's hit F10, and we're running it again. Demo float program point number, and then I enter a prompt. Okay, now I do syscall, and here I'm going to enter the number 0 0.45. Now, if you remember in class, we actually tried to convert that to a decimal, and or to a binary, and it turned out the bits after about six or so bits kept repeating, so we could never actually get 0.45 represented in binary. Well, let's see what happens when we try to enter this in and then print it back out. Okay. So at this point, I just read it in. So let's go look at my floating point registers and see how we get that 66666. Yeah, so it's repeating. Those bit patterns are repeating. Okay. All right, let's go back to the text. And let's see, V04, which means I'm going to do a syscall and print out a string. I printed out, you entered the floating point number. Now what I have to do is move that floating point from F0 to F12. And then I do load immediate V02 to print it back out. When I do syscall, it prints it back out. But look what we got here, 4499999. So we can't represent that exactly in binary. And I think we showed that in class because those bits kept repeating. All right, there you go. So to sum up here, what do you read into? You read into F0, you write out of F12. What do you set V0 to be? Well, you set V0 to 6 when you want to read a float, and V0 to 2 when you want to write a float. All right, I think that's good. I'm going to stop here.